This lesson is an introduction to a quadratic function. A quadratic function has the form y equals ax squared plus bx plus c. It is a curve, and it is also called a parabola. We want to see how the values of a, b, and c affects the curve, just as in the linear function where m and c will determine where the curve is placed and also how it's sloped. We'll now take a look at c, which in a straight line, c shows the y-intercept. And when c is 1, the line will cut at 1. C is 2, the line will cut at 2. And when c is negative 3, the line will cut at negative 3 on the y-axis. So similarly, the c in a quadratic function is also the y-intercept. So when c is 2, the curve will cut at 2 on the y-axis. And similarly, when it is 3, it will cut at 3. And when it's negative 4, it will cut at negative 4 on the y-axis. Now let us take a look at the next coefficient, which is the coefficient of x squared. We now want to see how a, which is the coefficient of x squared, changes the graph. Now let's see what happened when we increase the value of a. Currently a is 1, and when a is 2, the graph becomes narrower. And as it increases, it becomes narrower and narrower. And when it decreases, the graph gets wider. Right? So again, 4 is very narrow, but when it goes to 1, it becomes wider. The next thing we want to look at is that this curve here is called a minimum curve. And this is when a is positive. We have a minimum curve because there is a minimum value, and the minimum value is the lowest value of y, which is negative 4.25. And the lowest point here is 1.5 comma negative 4.25. So when a is positive, we have a minimum curve, and we can remember that by thinking that if we are positive, we smile. So when a is positive, we have a minimum curve which looks like a smile, and we have a minimum point and a minimum value of y. So when a is negative, we have the curve is inverted and we have a frown. So when a is negative, we have a maximum value of y. There's no more value above that. So the maximum value here in this case is 0.25, and we have a maximum point. So when a is negative, we frown. So when we frown, there will be a highest value, which is the maximum value, and we have a maximum point. Let us now look at another aspect of the graph. And here, a quadratic curve is symmetrical, which means that it can be divided into two equal halves. And the line of symmetry is the line that passes through the turning point or the lowest point, dividing the curve into two equal halves. The equation of this line is given by the formula x equals to minus b over 2a, b being the coefficient of x and a is the coefficient of x squared. For example, in this case here, b is 1, so we have negative 1 over 2 times 2. A is 2, so negative 1, which is negative b, over 2a, and a is 2, so 2 times 2, giving us negative 1/4. Now we could also get this equation by looking at 2 points which are on the same level, such as B and C. Now let us see what happened. Okay, so here the x values of B is negative 3, x value of C is 2. So if we average this, negative 3 plus 2 divided by 2, we will also get x equals to negative half. So usually we take one of the point is the y-intercept and the other point which is on the same level as the y-intercept to find the line of the equation of the line of symmetry. Okay, let us look at another example. Here, okay, now we have this equation here, and the line of symmetry is x equals to 0.5. Averaging the x values again at this level, we have negative 1 plus 2 divided by 2. That will give us half. Negative 1 plus 2 will give us 1, divided by 2 will give us half. Now we move on to the last aspect of a quadratic graph. A quadratic function can be used to solve a quadratic equation. In this case here, when the curve y equals to ax squared plus bx plus c cuts the x-axis, y is 0. And when y is 0, replacing the equation with 0, we get a quadratic equation. So at the x-axis, the function becomes a quadratic equation. And the values of x, or which are the x-intercepts, they are the solutions to the quadratic equation. For example, in this case, the graph cuts at negative 1 and 4. So negative 1 and 4 are the solutions to this quadratic equation. Let us now move to a new equation. And here we see that again we have two solutions, and in this case here, the curve cuts at only one point. So we have actually a repeated solution. So therefore, there is only one solution. If you look carefully, this is a perfect square. So when we have a perfect square, in our previous lesson, we learned that there are repeated solutions. So there is only one solution. So when the curve doesn't cut the x-axis, then there is no quadratic equations, so therefore there are no solutions. So when there are two intercepts, we have two solutions. One intercept, one solution. This is when we have a perfect square. And when there are no x-intercepts, then there will be no solutions. Right, now let us see what happens when b is 0. When b is 0, then we have the curve is in the middle, where the line of symmetry is the y-axis. So when b is 0, the line of symmetry is the y-axis. And if you were to take a look at this example, we have actually a difference of two squares, x squared minus 4. So when we have the curve where b is 0, that means you don't have any x term, then the curve is symmetrical about the y-axis, and we have a difference of two squares. So a difference of two squares, yeah. We have another example here, x squared minus 1, which is also a difference of two squares. The x-intercept also called the roots of the equation. This is the end of the lesson. Thank you.